Chapter 1, we begin with shear. Shear stress, this is in Newton per meter squared or Pascal. This is tau. So when the flow is moving along a direction, right, then you have shear stress. And this shear stress has a formula, okay, which is the dynamic viscosity multiplied by the velocity gradient. How do you see the velocity gradient? If I have a moving surface and a stationary surface, right, and this is going at, this is a height h, the velocity is a u, capital U. Okay, my curve I can draw like this. U. This is the velocity profile. Okay, it means that at the base is stationary, so the water particle next to the base follows the base velocity, which is 0. So you start from 0. As you go higher and higher to the other side of the surface, the velocity will start to be higher and higher until it is the same as this moving surface. Okay, so this is a velocity profile which you can get a gradient, okay, by this change in u over this change in y. So you can put it like this. Change u minus 0, because it's u minus 0, right? And this one is h minus 0. Okay, so you will be able to get a shear stress acting on the surface based on this formula. Okay, your shear force will be the shear stress multiplied by the area, okay, to be newtons. This is the shear force acting on, let's say I want to talk about the shear force acting on this table. So I have a flow going along this table. So the table will experience the shear force. Then multiply by this area of the table. Okay, shear stress times this area will get a shear force. And then, yeah. Next one is then we talk about pressure. So let's say this is the free surface. Okay, if there is an object below, okay, at a height, so the pressure acting at this point, okay, will be rho g h. Okay, this rho, right, is the density of the fluid. Okay, if this is water, then this rho will be density of water, which is 1,000 kilogram per meter cube. 我上镜了。你可以录到10点半啊。You can record until 10:30 4-hour video 啊。
So the vice cover of
啊，上 YouTube 啊？开玩笑，这样烂的 picture 上 YouTube， 哇 ，dislike 哎，等一下。
模范 picture of the smart man 单靠这个 video
Okay, wait yes. What else? So, then we talk about this, right? Buoyancy forces. Okay? Yeah. So if you have an object floating in the water, you will experience a buoyancy force. Okay? And it also have a weight. So, when this is in equilibrium, which means not moving, these two forces will be the same. Okay? So actually Fb equals to W. Okay? W is very easy. Mass of the object multiplied by G. Okay?
yes.
But buoyancy force is what?
Mass of this
Mass of displaced fluid, okay, multiplied by G. Okay, then the trick is in determining these two masses. This mass, of course, is volume of the object multiplied by density of the object. Okay, this one is volume displaced, which is this one, this volume. Okay, multiplied by what?
The voucher.
Density of the
Voucher.
fluid. Okay, fluid displaced must be density of the fluid. So these two will be the same. Okay, and of course the question will ask you something like, what is the density of the object? What is the density of the object? Or how deep? How deep is it? Okay, or how much is exposed above the surface? Then you can get the answers. Sorry? I'm so sorry. Okay, this is one question. This is one question. Okay, this is one topic, right? This is one topic. Then the next topic is on pressure and pressure head. Over here we talk about two different types of two equations. One is on stationary vessels. Okay, if I want to classify, it should be stationary vessels.
Not empty.
This one, the equation is absolute pressure is equals to atmospheric pressure plus gauge pressure. Okay, then the example I gave you was the car tire. Okay. Yeah, when you go and pump your tire in the petrol kiosk, the number that you enter is the pressure, is the gauge pressure, and that pressure is inside the tire. But it does not include the atmospheric pressure. So the actual total pressure inside the tire is the gauge plus the atmospheric pressure. Okay. And the other one is with flows, involving flows, which means if you have fluid that moves at a certain velocity, right? Then this will be stagnation pressure, which is total pressure. Okay, equals to dynamic pressure plus static pressure. Okay? Dynamic pressure will be related to the velocity of the flow. So it's half rho U squared. Okay? When you say U, rho, it is the density of the flow, the density of the fluid that's flowing, either oil or wind or water. Okay? The static pressure is the one that is not related to the velocity. For example, if I have a flow inside a pipe, okay, then I chuck in what you call a piezometer. It's basically a straw. You chuck it in, right? If the static pressure inside is higher than atmosphere, what do you think happens? Come out, right? But you won't. you will do this. So this amount is the pressure that is higher than the atmospheric pressure. This is your static pressure. Okay? H. So rho G H. This is your static pressure. Okay? The rho is the rho of this fluid. Okay? So to put it simply, so this is the static pressure. Dynamic pressure, they will all often tell you how much is this speed. Then you just multiply it inside to get the dynamic component. Okay? So stagnation is also called total. Okay, total pressure. Yes, usually they will sometimes give you this kind of value, say there's a certain height, or they just straight away tell you that it's some kilopascal of pressure. That is your static pressure. Okay. Then I go that way. Then finally is the thing called head. We have this, right? Okay. This is like this. Okay. This is called pressure head. And the units is what? Meters, because this one divided by this one will give you meter. Meters of fluid. Okay? What fluid? Yeah. Okay, never mind. To make it very easy to understand, pressure head is just pressure expressed as a length. Okay? The usual approach is always get the Pascal first. Always get the Pascal pressure first. Then you can convert to any head you want. Take for example, if my pressure is 30 kilopascals. Okay? Now I want you to tell me what is this pressure, right, in meters of water. So, straight away you use this, right? So pressure I put what? 30,000 lah. Then the density, eh? Density is the fluid that you want to express it. Just now I say express in meters of water. So the fluid must be water. So the density is the density of the water. Okay? So what is the answer?
30.
Wait. Wow, you're so powerful. 3.058 meters of water. Okay? The unit is this, it's not meters. If you give me meter, I'm not wrong.
Meter of
Must be the fluid, must have the fluid there. Okay? Now I want you to express this pressure in mm of mercury. So, what do I put? Mm of mercury.
760.
Density of mercury. 13,000.
13,600.
So this is what?
Meter of mercury.
Yeah, meters of mercury, but what's the value?
0.225.
Meters of mercury, but I want you to express in mm of mercury, right? It will be 225 mmHg. Okay? Pressure?